Alright, let's go through page 113. The T distribution, 610. Alright. So problem number 1 says, which T distribution would look more like a normal distribution? Degrees of freedom 40 or degrees of freedom of 60? And I'd say degrees of freedom of 60. If you're not sure how to check on that, you can always just take a look at Desmos. Hello. You have to sit on the opposite side. Don't mess with the computer though. Alright, so Desmos.
Oh, what are you doing over there, dude? You took my foot. Yeah, you the big ball.
So what you can do is just take a look at normal distribution.
What up? What?
Normal distribution is this.
Oh, isn't
and
that
if
sick?
you go and take a look at T distribution here.
What do you mean?
A lowered Subaru Outback.
It was hard. He's such a nice guy.
So T distribution, if I did
Okay.
T
I'm
distribution
sorry, I
40,
don't judge people like
that's
that.
pretty darn close. If we take a look at it.
But where were you, bro? I thought you were
And
gonna
then if I go to 60, I bet you might be a little closer.
Bro, you're like, I'll ask my mom.
So
and then no response.
the higher your degrees of freedom, the more it looks like a normal distribution. So that's pretty easy. Which T distribution shows the higher peak in the middle of the bell-shaped degrees of freedom of 5 or 20. So if you look at 5, 113. So 5 goes up to just under 0.4. And if I did T distribution of
4-pound trout.
T distribution of
4-pound trout. That's pretty good.
20. So the 20 has the higher, because the normal distribution actually is a higher peak than the T distribution. So the higher your degrees of freedom, the higher the peak becomes. Which T distribution shows the higher and far left, right, and left ends. The degrees of freedom of 20 versus 25.
The 20-cent bait.
So
You hope those on the line, you just
that one gets harder and harder to see.
catch them.
I would say I would not give you that kind of problem, because if you don't see a comparison on Desmos, it's kind of bad. Typically, it would probably be the lower the degrees of freedom, the more pushed down it goes. So I would say the 20 would have the lower degrees of freedom would show the higher at the right and left end, but this doesn't show it as well. And then show you calculator commands. What percent of the distribution with 9 degrees of freedom is greater than 1.15? So if we go here to, we have 9 degrees of freedom. And then we want greater than 1.15. So just type it in. So it looks like about 14%. What percent of the T distribution with 20 degrees of freedom will be greater than 1.15? And that would be 13.2% roughly. What percent of normal distribution is greater than 1.15? So if I go just to a normal distribution here, I shouldn't delete these, I should just turn them off. It's bigger than 1.15. So that one comes to about 12.5. What percent of normal distribution was within 2 standard deviations from the mean? Hello? Good to see you. 2 standard deviations below mean. Sorry, I kind of moved my chair. So if I go normal distribution, if I go from -2 to +2, so you're talking about 95.4. And then what percent of T distribution with 5 degrees of freedom is within 2 standard deviations of the mean? So degrees of freedom 5. If I go 2 distributions, -2 to +2. So that's 89%, so it starts widening out a little bit. And assuming that a college professor is using T distribution to assign the grades To each of his students using degrees of freedom as part of the curve on the most recent test, he chose 15 degrees of freedom. Show the calculator's command to answer this question. Well, we don't have to show calculator commands. We can just do this. Students who earned more than 2.65 standard deviations above the mean got an A, so 2.5, make this, take it back and make that infinity. So looks like about 1.2% are getting A's. Ooh, this is a tough teacher. What percent of A's will be given? Will be given the increase or decrease if you had 30 degrees of freedom. So if you had 30 degrees of freedom, just plug it in there. So that goes to 0.9%. So as the degrees of freedom goes up, the chances of getting the A in this professor's class is lower. Only students who scored below 3.5 standard deviations below the mean earned an F. So I can change this to 3.5 or below. So only students who scored below 3.5 standard deviations below the mean earned an F. So that would be less than 1% would earn an F if we were just doing the degrees of freedom of above. And then students between 0.5 and 2.5 standard deviations earn a C. So if I go 0.5 here, and I change that to 2.5, so we're still basing it on the 30. 30% would, 30.1% would earn the C. And sketch 3 different distributions. Well, you can easily plug that into Desmos, so don't worry about sketching that kind of stuff. All right, that was the homework work. Feeling all right? That was 6:10. So, plans for this week.
With CCSE.
I also got a
So
field
we'll
trip.
do 6:11, 6:12, then review, then do a test
What?
on Thursday.
Subaru place.
If we truly do get 14 inches of snow like they
We have to
predict
go.
on Thursday, I would say we'd have a snow day both Thursday and Friday.
That would go.
If, huh? That'd be dope, yeah. If we did have if we happen to have a, let's just put it in perspective. If we did truly have a
Then
snow
April's
day,
gonna be really easy.
okay, let me talk and I'll fill you in on what I do. Sorry to interrupt your conversation. If we did indeed have a snow day on Thursday, I would just cancel a chapter 6 test, and I know most of you guys would cry yourselves to sleep about that. Cool? I wouldn't be the guy, cause, so. Well, they're saying like, what did they say, 14 to 20 inches of snow on Thursday, something crazy? Yeah, I know. That's a lot of snow.
So it's supposed to start snowing on Wednesday night?
Wait.
I don't know. When
Yeah, it
I
says
look at my
13.
thing, it says there's only a 30% chance of snow on my weather app, and then I
Electric
see
Jeep.
down here on this, it said,
Oh, they did it on
right there,
purpose.
10 to 16 inches of snow expected on Thursday.
Has the snowstorm passed anywhere else yet?
I don't know. So, if that happened, it happens. I mean,
They took the,
so if we had Thursday snow day, Friday school, I'm not gonna give you the test on
what
Friday.
that's called? Activity. Where they're allowed
They
to
put a
fire
Jeep
on
on
these
fire?
schools.
This would be like the whole COVID
Has
year all
American
over
flag
again.
on
We
it.
had gotten Thursday,
Is that
we
when
stopped
they set
school
it
on
on fire?
Thursday after school and found out we'd have to show up on Friday, and then we had 2 weeks for spring break, and then we
That's fucking.
went to online
Let me
dorkiness.
see this shit.
But fortunately, this isn't
Got
COVID, this is
Twitter's when it's
snow.
at, bro. That's.
Alright,
Unless we make it.
Where is
Part
that?
two.
Oh, that was in
that
Atlanta.
could be, I don't want COVID part 2 ever.
That's fucking.
Alright,
Did you hear about the Texas man? that
my
cheated?
friends, I'm gonna be on
Went to jail for
page
10
44.
For 10 years because he found out his wife was cheating on him.
Look at the black.
Page
Killed his
44.
wife, like, on a
Alright,
video.
one mean t-test.
She's like, "Shit, you really want this?"
So-
Say hi to Jesus for me.
So I'm pretty sure we are all pretty happy finding the p-value. That's basically Desmos, right? Okay, I feel very confident that you know how to do that. You can find, if you use a t-distribution, this becomes on Desmos, this becomes a t-value. They just changed the lettering, that's just to know. The t-value again, the t-distribution gets closer and closer to a normal curve. The higher and higher and higher the degrees of freedom become. fact, that's why you have 30 as your basis, because at 30, the t-distribution is almost identical to the normal distribution. So the process will be the same. Looking for normality. So, a few things. Bless you. For a one-mean t-test, the normality assumption is satisfied even when sample size is very small, as long as the sample is not sharply skewed and has no outliers. This is a judgment call, but it's worth noting that a t-test is very robust. That is, it works very well even under conditions that are not ideal for small sample sizes. Shown are the 5 steps. Okay, state the null and the alternative. We've been doing that a lot. And remember, the null, N-U-L-L, you reject when our p-value is less than 0.05. And I would say that would also be the same if the t-value was less than that. And this would be in a one-tail situation. If it's two-tail, you have to double that. Okay? The alternative, if our t was greater than or equal to 0.05 or our p was greater than 0.05, then we would fail to reject the null. Did I say it right this time? Looking at my boys, did I say this right? Is that right now?
Yeah.
Less than 0.05, reject. Bigger than 0.05, fail to reject. Right? We good? Okay. Alright, then create a null hypothesis sampling distribution with 7 part positions, the sampling statistic and shading, calculate the p-value. You can turn your sample statistic into a t-score if you're using a t. State the conclusions, and then any assumptions. So, on page 45, they are talking about, page 45, they say, is the average price of gas in Colorado greater than $2.50 per gallon? Boy, what year are they all in? Okay. Random sample shows 20 gas stations, shows an average of 2.54 with standard deviation of 30. And then we're using an alpha of 0.10. Okay. Hey, friends. Shh. Alpha is related to our confidence interval. So how confident would we be? How confident would we be if we had an alpha of 0.1?
No. Or yeah, very high.
Yeah, how high?
Like right on the dot.
100 minus 0.10 is 90. So 90% confident if we had a confidence interval. Okay? It's that closely related. Yes, it does change slightly as you take like senior level in college statistics classes, but from here on out, you're set. As soon as you see the alpha value, you know that that's just whatever the alpha value is minus 100 is your confidence interval. Okay? All right, so they said that we have this average score of 2.50. They do a random sample of 20 gas stations, and they showed that our sample showed 2.54. 2.54, and standard deviation was what? 30. All right. So first off, this is going to be a t-distribution because there's only 20. We have the sample standard deviation as well. That also points to a t-distribution. So you have 2 things here that categorize why we would do the t-distribution. Okay? I can find my standard error, which is going to be, my standard error is going to be 0.3 divided by root 20. We can find that over here. Alright, so let's get rid of that. 0.3 divided by root 20. So our standard error is going to come out to, let's go with 0.07. Oops. So standard error is 0.07 rounded because we're dealing with money. So if I draw myself my normal distribution or my t-distribution, this is going to be the 250. This is gonna be 257. This is gonna be 264, 271, 243,
Fully legal age.
236, and 229. And then our sample was 254, so we're like here. So they're basically saying that.
Stock attachment.
Okay, so state our null and our alternative. Our null gas is equal to 250. Our alternative, we feel because our sample's higher, we're going to see G is greater than 250. So if we go find this on our T distribution, our degrees of freedom, we're doing 20. We had a sample of 20, so degrees of freedom would be 19. And I knew that we had a minimum value. Oh. Minimum value of 2.54.
What is our minimum? It says that's our average.
Yeah, I made a mistake. Alright, let me get that to infinity. I'm going to plug the standard error in there. The reason I'm plugging the standard error in there is the T distribution is revolving around 0. So I'll put 0.07 in there. Okay? So, our T value, which is related to our P value, is going to be 0.47. Is 0.47 a larger decimal than 0.05? So we fail to reject our null. Very good. So 0.47. This is our T value is equal to 0.47, which that is greater than 0.05. So we fail to reject our null. Which means we did not, so a big discrepancy, and I need to explain this over and over, and it's just fine. This does not mean that our null is true, it just means that we did not find within our sample evidence to go against our null. So we can't ever really say the null is true. That's the big thing with statistics. I know that some statistics teachers will say, we're going to accept the null. No, you don't accept the null. That's bad, dirty math. Okay? Don't be a bad statistician. This just means we did not find evidence to go against our null. Okay? Big idea on that. Alright, so 611, take the opportunity. I bet you could whip through this pretty quickly. Okay? So page 115, 116, we will go over tomorrow, but if you take a look at it, I think that's all it is, 115, 116, yeah, it works. And 612. Cool. Hey, tomorrow's lesson, their word problem for the thing says the Las Vegas casino wonders if their dice they're using are fair dice. Ooh, I like that. Anything's good for statistics.
Alright.